right, let's go ahead and complete our takeaways and of course ask ourselves what is still a little bit muddy so that we can really understand what we have to do to get better clarification. Please do that with deep thoughts so that you can develop further understanding. But I will now move on to the takeaways, or the final checkpoints, I should say. So let's see what the goal of this lecture really was and what we can now check off. First of all, I am now able to develop the shear force and bending moment functions. So that means in terms of x. And I really know how to do that now. We spent some time at the beginning of the lecture to do that. So hopefully we can all check that off. Then it should be clear to me why, and the key word here is why. So why a certain load case causes a specific or characteristic type of shear force and bending moment. So why is the function really dependent on the load case? And I hope that this lecture helped you to understand why that is the case. For me, I can check that off now, and I hope you check it off with me. I also understand why the shear force function is the derivative of the moment. So the shear force is the derivative of the moment. And again, we have assumed that before, but now you understand why that is the case. At least physically, mathematically, we have done it before. Last but not least, we are definitely now able to determine the internal force functions. In this case, we did it for simple beam structures, but I think you can extrapolate that for all the different load cases. So if you're able to do that, check it off with me, and we are now ready to really wrap up this lecture if we understand all this and take a look at the homework before we call it a day. All right, let's take a look at the homework, for which we are asked to determine the internal force diagrams via functions. You can see that the problems are actually not getting more complicated than before. The only difference now is that you have to describe everything in terms of a function. But let's take a quick look at each individual problem, just so that we can avoid any confusion. So let me tell you that here on the first problem, you shouldn't be surprised if the functions turn out to be very simplistic, because you have to only deal with concentrated forces, which are actually also acting in the horizontal direction and the vertical direction. Therefore, you have to worry about N, V, and M. But I'm pretty sure that this is a very quick problem for you, because all the load cases are very simple. And let's move on to the next problem, for which we actually look at a evenly distributed force throughout the entire length. And by the way, for this beam here, I recommend that you actually describe the support reactions and the internal forces and the maximum moment, which clearly the maximum moment is at the center here, that you describe those in terms of variables. So for this problem, I would just set A plus B plus C equal to L, and I would keep W as it is, and then find your support reactions in terms of L and W, and also find your maximum moment in terms of L and W. And if you do that right, and if you really do it consistently, you will find that your maximum moment, this is where you should arrive, that M max is equal to WL squared over 8. So if you do not arrive at this equation, please do not move on. Every engineer needs to know this equation, which is derived from this type of problem. And again, just to be clear here, because it's so important, so all this here is equal to L. And I want you to really arrive at this equation. I want you to derive it yourself, which you can do with the methods that we described in this lecture, because you will see this equation over and over and over again in your engineering life. So please go ahead and do that. And that's why this problem is actually fairly simple, because we don't want you to focus on the numbers. We want you to focus on reaching this result here. All right, let's go to the third problem, which is now very similar, except that you have to add a concentrated force. So you really have to deal with two domains, domain A and domain B. And I don't think I have to say much about this because it's very similar to what we talked about in the lecture, except in the lecture we didn't have a force here, but I'm sure you can piece that together. Let's look at this case now. It becomes more interesting as we go along. For this problem, you have 1, 2, 3, 4 domains. And it's actually interesting because you have a concentrated moment and then different load cases here to the right. But the concentrated moment is something that we didn't explicitly talk about in this lecture, but we have talked about it in the past. So I encourage you to piece that together as well. So let's move on to the next problem here, which is actually a cantilever problem. And notice that for the cantilever, you start here with x on the left to the right. And you therefore shouldn't be surprised if your life will be very easy because your first domain can be described without support reaction and your second domain can actually also be described without support reactions. But maybe you want to calculate them at the end just to verify your logic and to arrive at the right answer and to double check your work. But that, I believe, is everything we need to know for this problem here. Maybe I should also tell you that, of course, you deal with a triangular distributed force, which you know will end up in a parabolic shear force function and in a cubic moment function. All right, last but not least, we have this problem, which now is interesting because we start off with constant right from the start because we have support reaction here and our x is positive to the right. Therefore, you don't get away as easily, but don't worry, you only have to deal with 2 domains. And I believe once you reach problem F, after solving all the other problems, this will be a walk in the park for you as well. So I wish you good luck with that. And I believe that is everything we need to discuss for the homework. Please have fun solving these problems. Once you master that, I think you're more than ready to really master the majority of the difficult portion in this class. We will, in the future lectures, take it a little bit further and deal with hinged beams with frames, which means that we actually deal with vertical members. And then we will deal with roof frames, which have then sloped members. But that is something you don't have to worry about right now. I just want you to know that if you understand this in depth, you will really be ready to move on and follow on the following subjects. I will see you in those next videos. Until then, stay safe.